When designing an experiment, the choice of the most suitable experimental matrix is usually not straightforward. Several factors must be considered when choosing a design for our experiments. In this video, I have put together a flowchart to illustrate how to choose the best design for your particular case. So let's dive into it. We are going to start by selecting the set of factors you would like to study. Then, the first question is, what do we already know about them? Do all of them affect the response? If the answer is yes, it means we are already advancing our knowledge about the system. But let's follow the maybe for now. We will be back to the yes shortly. If the answer is maybe, it means we have to build a basic knowledge about the system we are studying. So we need to run a design to grow our understanding of the process and to select the most important factors that affect the response variable. It is usually a two-level design, full or fractional, and the choice between them depends on the number of factors we have to study. If we have 2, 3, or 4 factors, we can run a full 2 in the power of k design. However, if we have more than 4 factors, a fractional design is the best choice since a full factorial design will be very large. Note that the 4 factors appear in the 2 decision path. For 4 factors, I would say that the best choice is a full factorial design, but fractional designs also work. Now, if we have several factors and follow the path of the fractional designs, the next question is about the interactions. I understand that we hardly know about the main factors themselves, but the probably absence of interactions can lower the number of treatments that are needed to draw conclusions about the main factors. So suppose we cannot really tell anything about interactions. In that case, the safe path is to run a resolution 4 or higher design, where the main factors are not alias to any two-factor interaction that can potentially be significant. However, if interactions among factors are highly unlikely, we can run a resolution 3 or even a saturated design. Once we ran the experiment, be it a full or a fractional design, we need to analyze the resulting data and draw conclusions. Are the results conclusive? Was the overall objective achieved? Maybe the answer is yes. But the 2 in the power of k designs are usually screening designs that will give only an idea of the factors that affect our response. If we are looking for a deeper understanding of the behavior of the system, we need to go further. So based on the results of the 2 in the power of k design, we are going to select 2 or 3, maximum or 4 factors to be studied. And then we are back to our initial questions. Do all the factors affect the response? And now the answer is yes. So let's go to our next question. How many factors? If we had not come from the screening experiments, maybe we have several factors that affect the response. If it is the case, we must follow the path of the screening designs to select the factors that have a major effect on our response. But as we already came from the screening experiments, we already have a low number of factors, and then the next question is about optimization. Are we aiming for process optimization? The cases of no would be if we ran a low-resolution fractional design, selected 4 factors, and now would like to run a full factorial or higher resolution design to learn more about the interactions, or if we came from the beginning and have not performed any experiment yet. As we came from a previous 2 in the power of k design, the answer to the optimization question is probably yes. In this case, we need to run a design to fit a second-order model. And here an important note. We only run optimization designs with factors that knowingly affect the response. To select the design, we have to consider if we have any restriction for factors levels, some treatment combinations, or the number of runs. If we have no restrictions at all, we can run a central composite design. And this is the best scenario. However, maybe we have some restrictions. If we have limitations on the factor levels, meaning we cannot afford 5 levels of each factor, we can use a face-centered composite design. It is very similar to the central composite design, but uses only 3 levels of each design factor. If our restrictions are about some treatment combinations, for example, if we know that the treatments with all factors at their high levels or all factors at their low levels would return a bad or even inexistent result, we can run a box-benhken design that does not have treatments in the vertices of the cube. Finally, if we have limitations about the number of runs, and this is usually when we have 4 factors being studied, then we can run a small composite design that combines a fractional design and Excel points. Any of these designs have 3 or 5 levels of the design factors and can be used to build a second-order model for process optimization, meaning a maximum or a minimum in the response. After running the design, we need to analyze the results. And now, was the objective achieved? Probably yes. And if so, congratulations, you did it. I hope this video has helped you to understand a little more about what to take into account when choosing the most suitable experimental design for your particular system. If yes, give it a like and subscribe to the channel so you don't miss anything. Thank you, and I see you next time.